Oh my God.
Hello everyone, how are you all? Very good evening to all of you. I am fine, thanks for asking. I am good, I am good. Let's wait 2-3 minutes more. Let's see how many people are coming today within 9:05. Only 8 people till now.
शायद नोटिफिकेशन नहीं डाले क्या?
नहीं, अब तक तो नोटिफिकेशन नहीं आया।
बात अच्छा याद दिलाया, डाल देते हैं अभी।
Ai, tu jangan.
Baik. Baik. Baik.
Okay, let's start. Any doubt from the previous class? Hello, am I audible?
Yes, sir.
Yeah. All clear till the previous class?
Yes, sir.
Whatever we have discussed?
Yes, sir.
Sure.
Yes, sir.
Okay, that's great.
That's hot. Yes, sir.
All your complexity and everything is clear, right? Whatever we have discussed in the previous class. So yeah, let's start with today topic insertion sort. Fine. Let me just set up everything. Just give me some time. So can I assume that all of you can now at least do the bubble sort and the selection sort? Both of them can be done by you easily. Is it true or false? Okay. My screen is visible now.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, just wait for my VS Code to start. Okay, fine. Yeah, let's begin with insertion sort today. Okay, one question. If an array has only one element, let's say 15, is it already sorted?
Yes, sir. Yes, sir.
How many of you
Yes,
agree
sir.
with me here?
Agree.
Yes, sir.
Who doesn't agree with it? If an array has only one element, is it already sorted? Who doesn't agree, tell me.
Sir, repeat एक बार.
If an array has only one element, is it already sorted?
Yes.
How many of you don't agree with this? So if an array has only single element, it is considered to be sorted. Okay, nothing you can else do. No element is present, no comparisons, no swappings, nothing. It's already sorted. That's all. So, okay, let's make an array. Let's make an array. Let's say this is my array. Now, can you tell me one thing? Which part is sorted and which part of the array is unsorted? Can you tell me now? If single element is always considered to be sorted, which portion of array can be considered as sorted and which portion can be considered as unsorted?
Left side index 0 is considered as a sorted element.
Okay, if it is true that if an array has only single element, then the array itself is sorted, right? So I can say, okay, let's assume one thing inside my array, that the first element falls in sorted portion and the rest of the elements fall in unsorted portion. Okay, I can assume like this. Now, I want to, starting from the second element to the last, I want to insert them inside the sorted portion. I have to do something. Let's see what we can do. See, this 5 is already in the sorted portion, right? This 5 is already in the sorted portion. Now, all these elements, all the rest of the elements, I want to insert inside the sorted portion, right? Now see, 5 is inside the sorted portion. First element is 9. I want to insert it inside the sorted portion. So if I just insert it after 5, is it sorted? Now what happens? I have inserted it inside the sorted portion. This part becomes a sorted portion. This part becomes the sorted portion, and the rest 2, 4, 3, 1, this becomes the unsorted portion, right? Done. Inserted 9 into the sorted portion, and just by inserting it once, what we have got that, okay, 5, 9 is making the sorted portion correctly, and 2, 4, 3, 1 is remaining in the unsorted portion. Okay, now 5, 9 is inside the sorted portion. I want to insert 2 inside the sorted portion. What will I do? Where it should lie? First tell me, if 2 is to be inserted into the sorted portion, where it should lie, where it should go?
After 5.
5 and 9 is already sorted because this is the sorted portion. Okay, now this 2, at first let it compare with 5. Let me compare this with 9.
Right.
Okay, let me compare this with 9. 2 is what?
Less
2
than,
is what?
less than 9.
Less than 9.
Before
So
5.
2 must lie before 9 or not?
Yes.
2 must lie before 9. So what I can do? Swap them. Swap both of the elements. Now it will look like something 5,
2,
2, 9.
1.
Next, compare 2 with this 5. 2 is lesser than 5.
2.
So in the sorted sequence, what should happen?
Sure.
In the sorted sequence, 2 must lie before 5, right? So do what? Swap them. Then how it will look like? 2, 5, 9. Now the sorted portion is having 2, 5, 9. Let me write it here. Sorted portion is having 2, 5, 9, and 4, 3, 1 is lying inside the unsorted portion. This is sorted, this is unsorted. Okay, 2, 5, 9 is lying inside my sorted portion. In the unsorted portion, 4, 3, 1 is lying. Let's see them in the next page. 259. Sorry. 259 in the unsorted zone. Sorry, 259 in the sorted zone. What was remaining? 431. 431 in the unsorted zone. Okay, unsorted, sorted. Now, okay, next. Who will come next into the sorted zone? 4. So, okay, 4 comes inside the sorted zone. 4 comes inside the sorted zone. Now, 4 is less than 9. True or false? So 4 must lie before 9, right? Swap 4 and 9. Swap 4 and 9. Done. Next, see. 4 must lie before 5, right? Because 4 is less than 5. Do what? Swap 5 and 4. What will happen? 2, 4, 5, 9. Okay. 4 is less than 2. False. 4 is less than 2. False. So what will happen? No swapping is required now. This sequence becomes my sorted portion, right? This sequence becomes my sorted portion now. And what elements remain in the unsorted portion? 3 and 1. Now 3 will be coming inside the sorted portion. 3 will be coming. Okay, this is what? Now inside this 3 will be coming. So okay, 3 is less than 9. 3 is less than 9. Do what? Swap 9 and 3. How it will look like? 2, 4, 5, 3, 9. 3 is less than 5. Swap 3 and 5. 2, 4, 3, 5, 9. Okay, 3 is less than 4. Swap 3 and 4. 2, 3, 4, 5, 9. So, okay, no more swappings are required now. 3 is greater than 2, no more swappings. So, after bringing in 3 into the sorted zone, how it is looking like? 2, 3, 4, 5, 9. Right? And 1 is remaining in the unsorted portion.
Hello.
Yes?
Yeah, sir. Instead of comparing it with the largest value, we can also compare it with the minimum value, no?
Then,
Instead,
okay. Just keep on hold. See here. 2, 4, 5, 9, right? This was my array. I want to bring in 3. Now tell me, if I compare this with 2, what will I do next?
I will go to the next index.
Then
I will compare with the 4. If the value is greater than the insertion value, then I will put it inside.
inside what?
Inside 2 to 4, 3 after 2.
See, that's what effectively I am doing, right? That's what effectively I am doing.
You are comparing from the right side, na?
No matter what. If the array of the size, if size of the array increases, then effectively one time will come when both. If you need to check from here or here, it will not matter much.
Isn't it creating a, I think, a larger time complexity?
Is it? I don't think so. At the worst case, both will be same.
Yeah, but practically it will take much memory.
Is it? I don't think so. I'm using
Whether it's in a
no more
kilobyte,
extra space.
whether
I'm
it's-
using no more extra space here. How come it comes? Just I will take one input array and that will suffice for me to perform the
okay,
insertion.
that is totally fine. No issue.
Okay, next what will happen? Can anybody tell me? What is the sequence I have got? 2, 3, 4, 5, 9. This is my sorted portion.
Then
This is my
one will go.
unsorted portion. Now tell me what will happen. Who will tell?
One will go to
Now, what is happening? 2, 3, 4, 5, 9. 1 is getting inserted into the sorted sequence.
yes.
Okay, now I will compare 1 and 9. 1 is less than 9. True or false?
Swap. Okay. True.
Okay, then do what? Swap.
Yeah.
2, 3, 4, 5, 1, 9. Next, 1 is less than 5.
Swap again.
Do what?
Koni चाहिए?
Swap
Ay,
again.
Koni.
1 is less than 5, do what? Swap again. 2, 3, 5, sorry, 1, 5, 9. Now next, 1 is less than 3, swap. 2, 1, 3, 5, 9. 1 is less than 2, swap. What will happen? Have I missed anything? 4, right? Missed 4 here. 2, 3, 4. 1 will be compared with 4 first. And then 1 will be compared with 4 first. And 1 and 4 first will be swapped. 2, 3, 4, 1, 5, 9. 1 is compared with 4. 1 is less than 4. Do what? Swap them. What will happen? 2, 3, 1, 4, 5, 9. Now next, compare 1 with 3. Is it lesser than? Swap. 2, 1, 3, 4, 5, 9. Next, 1 is less than 2. Swap them. 1, 2, 3, 4, 5, 9. Okay. Done this part. Sorted my entire array. Tell me, is the approach understood to all of you? How we are doing? Now let's come to the code. How will we code this insertion sort part? Okay. Okay, fine. So def insertion sort. Let's do it like this. Okay, let's take an array of size n inside. Now what we will do? Okay, what we have seen, that the first element is already sorted, right? What lies in the sorted portion already inside my array ARR? The first element, right? So I can effectively start to insert inside the sorted array from index 1, right? 0th index I can leave. I can effectively start from index 1. For I in range, start from 1, go up to n, or end at n. Right? Now what I have to do? Check the previous indices, right? Check the previous indices for j in range I minus 1. And I have to check till index 0. So where shall I stop? Minus 1. And number of steps should be minus 1. Correct or wrong? Okay, fine. What I have to do now? If okay, no. Starting from I, not j.
So step समझा नहीं मैं, step -1 क्यों आएगा?
बैकवर्ड जब ट्रैवर्स करते हो तब तो -1 देना पड़ेगा ना.
तो 4i initially 1 है.
क्या? सॉरी,
Initially 4i in range 1n आया ना?
हाँ, I स्टार्ट होगा 1 से.
Initially i 1 से स्टार्ट हुआ. तो -1 स्टेप माइनस में 0 में चला गया.
हाँ,
ठीक है. तो then
one thing, it is not required to be -1.
Got it.
Yeah, okay, thanks. It will be effectively ending at 0 only, okay? Not required of -1. Okay. If array of j is greater than array of j minus 1. If this condition is true, how will we swap? Can anybody tell me? Array of j minus 1 will be equal to what?
Array of j minus 1.
Array of j minus 1, array of j.
Comma array of j.
Bus. Swapped, right? Keep on swapping. Fine, this part is done. My array is sorted, and at the end, what will I do? Return my array. Done. Let's declare an array. What example have we taken there? What example? 592431, right? 592431. Five, 9, 2, 4, 3, 1, right? Okay, print insertion sort of array.
सर एक और वैल्यू पास करने का है ना
Array और इसकी length, right? Okay, yeah. Let's try printing this now. Okay, what is it? Sorry, have done that in reverse order, right? It got sorted in reverse order. Okay, fine. Getting the sorted array. 1, 2, 3, 4, 5, 9. All done. Sorted it successfully. What we have done, see here. What was my initial array? What was my initial array? 5, 9, 2, 4, 3, 1. Okay, so what I did for I in range 1 to n, I starts here. I starts here. And okay, j also for each I, j will be starting at I. J will be first pointing here where I is pointing. Now next. Okay, see here. What is the condition? Can anybody tell me here? For what condition this jth loop will be running? Who can tell me? This will be, j will be initialized with the value of I. Jth loop will be running till the time j is greater than 0. And for each increment, j will be decreased by 1. Am I correct or am I wrong? Tell me.
सर 9 to 5 तक रहेगा.
First tell me this. Am I correct here?
Yes, you are correct here.
For what conditions the jth loop will be running? Who can tell me? J will be initialized at value of I. J will be
J decrease होता जाएगा जैसे ही वो एक step backward जाएगा.
Yeah. J will be running till the time j is greater than 0. See here, ending point is 0. J will be decreased by 1 with each iteration. Tell me, who are agreeing with me here that yeah, this jth loop will be running like this?
Yes, yes.
Okay. How the jth loop will be running? J will be first initialized at I. J will be greater than 0. And for each iteration, once the entire thing have been executed and it is going back to the jth loop, value of j will be decreased by 1. That's all. Okay. J starts at I. Wherever I is pointing, j points here. What will happen? If array of j is lesser than array of j minus 1. Array of j, if j is pointing here, j minus 1 will be pointing here, right? Now see, is array of j lesser than array of j minus 1? Is it correct? False. So what will happen? This block will be skipped. It will go back to the loop. Okay. Now value of j decreases by 1. or j points to the 0th index. J comes here and j points to the 0th index. So j should be greater than 0. So this loop terminates. Okay, and it goes back to the ith loop. Okay, now value of I increases by 1. Value of I increases by 1. Fine. Value of I increases by 1. J, where does j starts? J equal to I. Just wait. It is going back to the ith loop, right? Now it will come here first in the jth loop. J points here. J initializes at I. J points at the value at the index where I is pointing. Okay, fine. Now it will check if array of j is lesser than array of j minus 1. If j is here, j minus 1 is here, right? J points at index 2, then j minus 1 will be at index 1. Then it will check array of j, is it lesser than array of j minus 1? Then what's the result? 2 is lesser than 9, it will be true. Then swap array of j and array of j minus 1. What will happen? 2 and 9 will be swapped. What's the value I'm getting? 5, 2, 9, 4, 3, 1. Okay, fine. This is done. It will go back to the j loop. Now j points here. I points here only, j points here. Hence j minus 1 will be pointing here. Now again, it will come and check this condition. If array of j is lesser than array of j minus 1, is array of j lesser than array of j minus 1? True, right? What will happen? Both of them will be swapped. How it will be looking like? 2, 5, 9, 4, 3, 1. See, this is my sorted portion 2, 5, 9, and this is my 4, 3, 1 sorted portion. Okay, successfully inserted this 2 into this sorted portion. That's all. Okay, this is done. This part is done. After swapping, it will go back to the jth loop, right? Now j comes here. Now j comes here. So j should be greater than 0, right? But j is having value 0 here. Why? It is pointing to the 0th index. So this loop now terminates. And it will go back again to the ith loop. It will go back again to the ith loop. Fine. Let me erase everything. What was the value we have got? 2, 5, 9, 4, 3, 1. This is done. Okay, now I goes one step ahead. I goes one step ahead at 4. This 4 is to be inserted into the sorted portion 259. Okay. Now j will be initially pointing here. It will come inside and jth loop will start. J will be initially pointing where I is pointing. Okay, now if j is here, j minus 1 is here, right? J minus 1 is here. Okay, now check. It will come inside the if condition. If array of j is lesser than array of j minus 1. If 4 is lesser than 9. Is it true? True, right? Then what will happen? Swap both of them. Swap both of them. Come inside this line and swap both of them. So how it will look like? 2, 5, 4, 9, 3, 1. Successfully swapped. Okay, next, what will happen? Where j will be going? J will be one step back. J will be now pointing here. J will be pointing here. Now, if j is here, j minus 1 will be here, right? I is pointing here at this position. Now again, check this condition. If array of j is less than array of j minus 1, is it correct? Array of j is less than array of j minus 1. 4 is less than 5, swap both of them. Now how it will look like? How it will look like? 2, 4, 5, 9. Next 3, 1. Okay, now j will be coming here. J will be coming here. And j minus 1 will be pointing here. Right? J was initially here. J will be going one step back. So J is here now, and J minus 1 points just a index back. So compare both of them. Is 4, check this condition. If array of J is lesser than array of J minus 1, is 4 lesser than 2, correct or false? False. So what will happen? This line will be skipped. It will go back to the Jth loop. Now J comes one step back. J comes one step back. Since value of J is now 0, this loop terminates. It goes back to the ith loop. It goes back to the ith loop. I was here. Now I will go one step ahead into this 3. So after this, what we have got? 2, 4, 5, 9, 3, 1. See, this 2, 4, 5, 9 I am getting as my sorted portion. And this is the remaining unsorted portion. Now I will be pointing here. That means, okay, now insert this 3 into this sorted portion. Now let's see how it works. Two, 4, 5, 9, and this 3, 1, right? I points here. I now points here. So J will be starting from here. It will come inside the Jth loop, and J will be starting where I is pointing. Okay. Now what will happen? Can anybody tell me? What will happen? If J is here, J minus 1 will be pointing here. Now check the condition. If array of J is lesser than array of J minus 1. If array of J is lesser than array of J minus 1. Array of J is lesser than array of J minus 1. True. Do what? Swap array of J and array of J minus 1. Swap 3 and 9. What will be happening now? How it will look like? 2, 4, 5, 3, 9, 1. I is here. Now J, since swapping is done, it will go back to the Jth loop again. J will be going one step back. J now will be pointing to this 3. If J is here, J minus 1 will be here. Now check. Is 3 less than 5? Is 3 less than 5? Again true. Do what? Swap both of them. How it will look like? 2, 4, 3, 5, 9, 1. Okay. I is pointing here. Swapping part is done. You do what? Take this J one step back. Take this J one step back. J was here. At this index, J will go one step back. So if J is here, J minus 1 is here. Now check. Is 3 lesser than 4? Is it true? Again, it is true. Do what? Swap them. It will look like 2, 3, 4, 5, 9, 1. I is pointing here. And J was pointing at this 3. It is swapped with this 4. So it is looking like this. Now this swapping is done. It will go back to the Jth loop again. It will go back to the Jth loop again. It will go back to the Jth loop again. Fine. So now J points here. J points at this position. J will be decreased by 1, value of J. So now again check this condition. If array of J lesser than array of J minus 1, is it true? Array of J lesser than array of J minus 1. 3 is greater than 2. So this condition is false. What will happen? This line will be skipped and it will go back to the Jth loop. J comes one step back. Done. J comes one step back. Since value of J here becomes 0, what will happen? This loop will break and it will go to the ith loop and value of I will be increased by 1. It will now point here. So after this ith iteration, what we have got? Sorted portion to be 2, 3, 4, 5, 9. Unsorted portion, only one element is remaining, that is 1. Okay, now let's see what will happen. Two, 3, 4, 5, 9, and 1, right? Now I will be pointing last at this 1. So J will start here. J and J minus 1 first will be compared. J and J minus 1. Is 1 less than 9? True or false? True, right? What will happen? Both of them will be swapped. How it will look like? 2, 3, 4, 5, 1, 9. I pointing here. Now, J will go one step back. J will go one step back. If J is here, J minus 1 is here. 1 and 5 will be checked. 1 and 5 will be checked. If array of J is lesser than array of J minus 1, swap them. Is it true? 1 is less than 5? True. Swap them. How it will look like now? 2, 3, 4, 1, 5, 9. Okay. After swapping, it will go back to the jth loop. Value of J will be decreased by 1. J comes here. I stays wherever it was. Now again, if J is here, J minus 1 is one step back of J. So 1 is compared with 4. Is 1 less than 4? True. Swap them. How it will look like? 2, 3, 1, 4, 5, 9. I here. Next, J was here, right? It will go back to the jth loop after the swapping, and value of J will be coming one step back. If J is now pointing at this one, J minus 1 is here. Array of J is lesser than array of J minus 1. Compare. True. Do what? Swap them. How it will look like. How it will look like? 2, 1, 3, 4, 5, 9. I stays as it is, wherever it is. Now J was here. It will go back. It will go back to the jth loop again. After the swapping is done, it will go back to the jth loop again, and value of J will be decreased by 1. Value of J will be decreased by 1. Now see, is 1 lesser than 2? J and J minus 1. Compare both the elements. J at J and J minus 1. Is 1 lesser than true? Sorry. Is 1 lesser than 2? It is, right? Swap both of them. How it will look like? 1, 2, 3, 4, 5. Okay. Value of J after the swapping is done, it will go back to the jth loop again. J comes here. Since J is pointing at the 0th index, this jth loop terminates and it will go back to the ith loop. Okay. Now see, value of I was pointing here, and what was the value of I? In minus 1. Now I goes one step ahead. I's value becomes n. I's value becomes n, and n is the ending point. So this ith loop also terminates. Ith loop also terminates, and whatever is the array we have got 1, 3, 2, 5, 9, this gets returned inside the print statement. That's all. Hence we are able to print 1, 2, 3, 4, 5, 9. Successfully sorted using insertion sort. Now tell me what's the doubt. What doubt you are having with insertion sort? Can you do it?
So the value of n is considered as the length of the list, right?
Yeah.
Okay.
Tell me, any doubt regarding insertion sort? All clear? What we are doing, all clear? Please tell me. Okay, let's go ahead with the time complexity part. Let's go ahead with the time complexity part. Okay, can anybody tell me what is the worst case? What happened, man? Can anybody tell me what is the worst case for this?
Yeah.
Smallest number at the last.
Okay, only
Descending order,
smallest.
sir. Descending
The-
order.
See, if the array is in descending order, let's say
Yes.
6, 5, 4, 3, 2, 1. Length of the array n is equal to 6, let's say. Now see. Okay, fine. So what will happen? This 6 is already sorted, right? This 6 is already sorted. Am I correct or wrong?
Yes. Correct.
And this falls under the unsorted zone. 5, 4, 3, 2, 1. Now what will happen? 5 will be inserted into the sorted zone, right? 5 will be inserted into the sorted zone. Correct or wrong? 6 is
Correct.
into the sorted zone already. 5 will be sorted. Now tell me what will happen. 5 and 6 will be compared. 5 and 6 will be compared and will be swapped, right? Correct or wrong? 5 will be compared with 6. Since 5 is lesser than 6, they will be swapped. 5 and 6. Okay. Swapped. This is coming onto the, sorry, what is happening? This is coming into the sorted zone now, and this 4, 3, 2, 1 is coming into the unsorted zone. How many swappings we have done here? 1. Correct or wrong? How many swapping we have done? 1. Now next. Next 5, 6 into the sorting, into the sorted zone. 4, 3, 2, 1 in unsorted zone. Which element will be now coming inside the sorted zone? 4, right? 4 will be coming inside the sorted zone. Now 4 compared with 6. Let's, okay. All the 3 are inside the sorted zone. 4 compared with 6. 4 is less than 6, swap. What will happen? 5, 4, 6. Now again 4 is less than 5. Swap. Correct or wrong? How it will look like? 4, 5, 6. Okay. Swapping's done. Sorted zone is looking like 4, 5, 6. Unsorted zone is looking like 3, 2, 1. How many swappings we have done in this case? In this case, how many swappings we have done? 2. Done or not? Exactly swapped twice. First we have done compared 4 and 6, swapped, then compared 4 and 5, swapped. 2 swaps we have done here. So add 2 more here. 2 more operations we have done. Right? First operation was when we have swapped 5 and 6, and 2 more operations next when we have swapped 4 and 6 and 4 and 5. This part is done, right? Okay, how my sorted portion is looking like now? 4, 5, 6, and unsorted as 3, 2, 1, right? Now 3 will be coming inside the, 3 will be inserted into the sorted zone. 3 will be inserted inside the sorted zone. Now how it will look like?
4, 5, 3, 6.
4, 5, 6, 3, right? Initially it is 6.
Yeah. Okay.
Okay, now 3. Compare 3 with 6. Compare 3 with 6. Is it lesser than 6? What will happen? Swap. First swap. First swap. What is happening in the first swap? 4, 5, 3, 6 it is becoming. Now next, 3 will be compared with 5. 3 will be compared with 5. Is it less than 5? So do what? Swap. So in the second swap, what we will do? What we will do? Swap 3 and 5. 4, 3, 5, 6. Now next, 3 and compare 3 and 4. 3 is lesser than 4, swap it. This is my third swap. So 3, 4, 5, 6. This is becoming, right? Got my sorted zone as 3, 4, 5, 6. Unsorted as 2, 1, right? How many operations we have done here? How many swappings? 1, 2, 3. Add it to the number of operations. Add it to the number of operations. Okay, fine. So how my sorted zone now is looking like? 3, 4, 5, 6, right? And 2, 1. This is the unsorted zone. Now insert 2 into the sorted zone. How it will? Initially, how it will be? 3, 4, 5, 6, 2. Now, yeah, start. 2 and 6 compare. Compare 2 with 6. What will happen? Is it lesser than 6? Yes. Swap. First swap. How it will look like now? 3, 4, 5, 2, 6. Next, what will happen? 2 will be compared with 5. 2 will be compared with 5. Now, second swap. 3, 4, 2, 5, 6. 3, 4, 2, 5, 6. Fine. Second swap. Now 2 will be compared with 4. 2 will be compared with 4. What will happen?
क्या भाई इतना सन्नाटा क्यों है? हेलो
हेलो
इतना सन्नाटा क्यों है?
कल रात हो गए ना।
तो डीजे बजाएंगे अभी।
बजा लो मौका मिला है, मौके का फायदा उठा लो।
मौका मैच चालू होगा ना अभी।
हाँ
24 को
24 से
मैच तो रोज आता है किसी न किसी का।
नहीं, मौका वाला 24 से है ना।
हाँ
मौका वाला ही देखने का होता है ना।
तो बोर हो रहा है आज का लेक्चर।
आज कम आया स्टूडेंट।
अपना कोई व्हाट्सएप पे ग्रुप वगैरह बना हुआ है क्या?
हाँ है ना भाई।
तो मैं ऐड नहीं हूँ।
एक नंबर नोट करो और उस पर पिंक कर दो।
बताओ।
75880
75880
80420।
80420।
Yes.
75880 80420 हाँ।
Yes, yes.
Sorry for getting disconnected for a while. Let's start again.
रहमान सर अपने को डिजेंगो वगैरह सिखाएंगे क्या?
क्या?
अपने को डिजेंगो वगैरह सिखाएंगे क्या?
ना, ये तो हम नहीं, ये तो कोई और सर सिखाएंगे।
पाईटॉर्च डिजेंगो वगैरह है क्या अपने सिलेबस में?
ना, जैंगो है शायद तुम्हारे सिलेबस में। पाईटॉर्च चांसेस लगता नहीं। पाईटॉर्च
यार बहुत हाई लेवल का काम है।
सर जैंगो नहीं है
क्या है फिर? तुम लोग का बैकएंड में क्या यूज होगा?
बैकएंड में तो नोड जेएस वगैरह है।
अच्छा ठीक है, तब तो जैंगो नहीं, नोड जेएस सीखोगे, पैकेज वगैरह बनाना वगैरह वगैरह। Okay, see here. What will happen? Next, 2 will be compared with 4 in the second swap. Is it? No, sorry. In the third swap, 2 will be compared with 4. What will happen? 2 is lesser than 4. Swap. In the third swap, Do what? Swap 2 and 4. How it will look like? 3, 2, 4, 5, 6. Done. Now next 2 will be compared with 3. Is 2 less than 3? It is, right? Then what will happen? The fourth time do what? Swap 2 and 3. 2 here, 3, 4, 5, 6. How many operations we have done here? How many swappings? How many swappings? 4, right? Add here. Okay, so what is coming inside my sorted portion? Who will tell? How many elements are inside my sorted portion and how they are looking like? 2, 3, 4, 5, 6, right? This is my sorted portion and leftover is 1 inside the unsorted portion. 1 will come inside now. Okay, what will happen? Compare 1 and 6. Is 1 less than 6? Swap. What will happen? First swap. What will happen? 2, 3, 4, 5, 1, 6. First swap. Next what will happen? 1 will be compared with 5. Is 1 less than 5? Swap. Second swap. 2, 3, 4, 5. 4, 1, 5, 6. Next. Compare 1 with 4. Is 1 less than 4? Swap. Third time. 2, 3, 1, 4, 5, 6. Now next, compare 1 with 3. 1 is less than 3, swap. Fourth time. 1 is less than 3, swap. Fourth time. How it will be? Looking like now 2, 1, 3, 4, 5, 6. Compare 2 with 1 now. 1 is less than 2, swap the fifth time. 1, 2, 3, 4, 5, 6. All swapped. How many swappings we have done? How many operations? 5 operations. Okay, added it. Anything else left? All sorted, right? Entire array is sorted. Now, how many operations we have done here for sorting the entire array? 1 plus 2 plus 3 plus 4 plus 5. For array of length
N minus
6. For array of length 6, I say that number of operations I have done 1 plus 2 plus 3 plus 4 plus 5. So, who will tell me if array is of length n, what will be the number of operation in worst case? Worst case.
N minus 1.
Is it?
No.
Is it only n minus 1? Who will give the answer?
No, sir.
N minus-
For any
N
array of length
into-
n, in worst case, what will be the number of operations? 1 plus 2 plus 3 plus 4 plus till n minus 1. Am I correct? Tell me. If
Yes,
for
sir.
any array
N
of
whole into
length
N
n,
whole into N.
sorry, if for array of length 6, I am getting sum of operations to be, number of operations to be 1 plus 2 plus 3 plus 4 plus 5. See, at n minus 1, it is ending. So for any array of length n, into the worst case, what I am getting? 1 plus 2 plus 3 plus 4 plus till n minus 1. This will be true. So what is the time complexity? I can say big O of. Okay, let's not. What is the sum of it? Who will tell? N
Sir,
into n.
n minus
N
1 upon
minus
2.
1
By
by 2
2.
divided by 2. Yeah.
So what is the time complexity? Big O of n square by
N
2
square.
minus n by 2. Correct?
Yeah.
Ignore this. Lesser power. Ignore this. 2 is a constant. Ignore. What is the time complexity?
N square.
N square.
Big O of n
N
square.
square.
Okay. Now there is a catch here. There is a catch here. Just it's not ending. The story is not ending in the worst case. Definitely, the worst case time complexity is big O of n square. Till here, is it clear to everyone? Tell me first.
Yes,
Is
sir.
it clear or not?
Yes,
All
sir.
of you.
Yeah.
All of you.
Okay.
Yes, sir. Clear, sir.
Yes, sir. Yes.
See here. Now, okay, observe what will be the best case. Can anybody tell me?
Array is already sorted.
So only one
Wait,
element.
Sorry.
Best case. Array is already sorted.
Yeah.
1, 2, 3, 4, 5.
Big O one.
So now, what will be the time complexity? Can anybody tell me?
What?
Who will tell?
Big of 1. 1 0.
N.
Who will
Sir,
tell?
n.
Big of. No,
N,
big of
sir.
1 is
Order
not
of
the
n.
answer.
N, sir. N.
Yes. Big O, whoever have told big order of n, this is the correct answer. Now see what is happening. 1, it is already sorted, right? Already sorted. Correct or not? 1 is already in the sorted zone. 2 is getting inserted. 2 is getting inserted. Now what will happen? 2, when I am trying to bring in 2 into the sorted zone, I will compare just once, right? I will compare once. Is 2 less than 1? Is 2 less than 1? Then what will happen? Then what will happen? No swapping.
No
Sir.
swapping.
No swapping. Then what will happen?
Loop terminated.
Only one comparison is here. Only one comparison is here. 2 is compared to 1, then nothing is happening. Then nothing is happening. So for comparing, what we do? For comparing whether 2 is less than equal to 1 or not, how many operations we require?
One operation.
One operation, correct? Now again, next what will happen? This got inserted. So how the insert sorted portion is looking like 1 and 2. Unsorted portion 3, 4, 5. 3, 4, 5. Okay, fine. Now next 3 will be inserted. 3 will be what? Compared with 2. 3 will be compared with 2. Is it greater than 2? No. So effectively no more comparisons are required. What I can say, 1, 2, 3 comes inside my 3 will be lying after 2 only, because no more swappings are, no swapping is effectively done because 3 is greater than 2. 1, 2, 3 comes into my sorted zone, and 4, 5 comes into the unsorted zone, right? So for comparing 3 with 2, how many operations we have done?
One operation.
One operation. Now see here, 4. 4 will come inside. 4 will come inside. 4 will be what? Compared with 3. Compared with 3. Is 3 greater than 4? Is it true? False. So no more swappings are required. How many operations I have done to compare 4 with 3?
Same one.
One operation, right? Effectively one operation. Now sorted zone is 1, 2, 3, 4, and unsorted zone is 5 only. Now see, 5 will be compared with 4 again. 5 is lesser than 4. Sorry, 5 is greater than 4. What will happen? No more, no swappings are required. 1, 2, 3, 4, and this is 5. 5 will be coming at the end of
So
that.
ultimately, number of operations on a particular step decides the time complexity.
Yes. So for doing this, for comparing 5 and 4, what I have done? How many operations? How many operations? One operation for comparing 5 and 4. So how many operations we have done? 1 plus 1 plus 1 plus 1, right? 4 operations for array of length n. So can I say for any array of length n, for any array of length n, I do exactly n minus 1 operation in the best case? Can I say that? For any array of length
Yes, sir.
n, I do n minus 1 operation in the best case. That's all. So what's my time
तो
complexity in the
अगर
best
इस केस में
case?
अगर इस केस में एक स्टेप पे दो ऑपरेशंस होते तो n-2 हो जाता.
Yeah.
Okay.
n minus 3 2n हो जाता, 2 steps होते भाई, 2n minus 2 होता. तो effectively what's my time complexity? Big O of n minus 1. 1 is what? Constant, ignore this. So what's the effective time complexity? Big O of n. Got it? How we are doing this?
Got it.
All of you, is it clear? Tell me.
Yes, sir.
Okay, now tell me, is my code following this, that in the best case my code will be giving big O of n time complexity? Whatever code we have done, whatever code we have written, is it following this rule that yeah, big O of n time complexity will be given by it? This is my code, right? Now judge. Take 2 minutes and think whether this code will be running big O of n time in big O of n time for what? The best case. Or it will be giving big O of n square operations only even for the best case. Think for it 2 minutes, then let me know.
Sir, could you repeat the question?
Tell me whether my code, the code that we have written for insertion sort, will it be acting in big O of n time for the best case, or will it be giving exactly big O of n square operation for best case also?
It will be a big O of n square.
Yeah, you are correct. So this code will definitely give big O of n square in best case also. In best case also, this code will act in big O of n square only, not in big O of n. I will, so it is your task for today, judge that why it will give big O of n square in best case also. Okay, and come up with a solution how we can reduce this in big O of n. This is your task for today. Tomorrow I will be discussing. Okay, all done. I have given you the answer. This code will run in big O of n square only, even in the best case. So your task is reduce the time complexity to big O of n for the best case using this code. Some conditions is required, perhaps you have to do that.
Or if we give the array in ascending order also, it will give.
Yeah, it will go big. It will do in big O of n square only. This is your task for today. Take that. Okay, tell me, all clear whatever we have done? Whatever we have done, all clear?
बबल सॉर्ट में इसको कर देंगे तो ये big O of n बन जाएगा.
ये तो बबल सॉर्ट है ही नहीं. Tell me, all clear whatever we have discussed till now? Please have some response so that we may proceed ahead. Don't worry on the code part. Even if you cannot do, we will discuss it tomorrow. But yes, try coming up with some solution that, yeah, what's happening inside the code and how we can reduce the time complexity. Okay, fine. Next topic is merge sort. The last topic that we will take in sorting, merge sort. Please tell me, are all of you clear with whatever we have discussed?
Yes, sir.
Sure or not?
Sure.
तो सर वो नहीं करवानी है आपने हीप सॉर्ट और बकेट सॉर्ट वगैरह?
नहीं, तुम्हारे सिलेबस में नहीं है हीप सॉर्ट. हीप्स में हो. अच्छा ठीक है, हीप सॉर्ट जब तुम्हारा हीप डिस्कस होगा उसके बाद ही कर सकते हैं ना.
हाँ, बट स्टिल बकेट सॉर्ट भी पड़ा है.
नॉट नेसेसरी. बकेट सॉर्ट एज पर द स्टैंडर्ड उतना नहीं है, उतना रिक्वायर्ड नहीं है. Okay, so we will take merge sort, and for this, are all of you clear with recursion? Tell me. So using recursion now, we will do some sorting, and that sorting is called merge sort.
सर रिकर्शन नहीं समझ में आया था.
चलो देखते हैं कैसे इसमें recursion लगता है. Last topic of sorting we are gonna take is merge sort. Okay. So how merge sort works? How merge sort works? This is an array. This is an array. 2, 6, 5, 9, 3, 4. Okay, can anybody tell me if I divide the arrays into halves? Divided my array into 2 halves. Okay, now sort the arrays individually. What the result I will get? Sort the arrays individually. What result I will get? Tell me.
2, 5, 6.
9.
3, 4, 9.
Okay, this will be 2, 5, 6, and this will be
3, 4, 9.
3, 4, 9, right? Fine. Okay, now what can I do so that some operations on these two arrays I will do such that they will be collectively sorted. Let me make another array. Okay. Now using these two arrays, okay, these two are arrays that I have got. I will be arrange them in certain manner such that all the elements inside this array will be sorted.
Okay, so it will be like merge break, तो then last में sort हो जाएगा.
Using elements of the first and the second array, I will arrange all the elements of the first and the second array inside my this empty array, okay, of size 6, such that entire elements of this array become sorted. Okay, okay, let's keep a pointer here I, and let's keep a pointer here j. Compare which one is smaller, 2 or 3, which one is smaller?
2, sir.
Copy it here. Copy it here. Move I one step ahead. Next, compare again. Which one is smaller?
3.
Ith element or jth element? 3 or 5. Which one is smaller? Copy it here. Now, since I have copied 3, move j one step ahead. Move j one step ahead. Fine. Again, compare I and j. Which one is smaller, 4 or 5?
4.
Which one is smaller, 4 or 5? 4.
4.
So do what? Copy 4 here. Copy 4 here at the first empty slot. Copy 4 and move j one step ahead. Now again compare. Which one is smaller, 5 or 9?
5 is a smaller.
5.
Now copy 5 here move j, move I one step ahead. Again compare. 6 or 9, which one is smaller?
6.
Copy it here. Okay. Anywhere else I can be moved. I will be going outside this array, outside the first array. Only one element is remaining inside the second array. I can simply copy it here. Is the entire array getting sorted?
Yes, sir.
So what we have done, sorted the halves. 2 halves, divided entire array into 2 halves, sorted them individually, and then what? Compared element by element from the first and the second array. And then done what? Compared and merged them into a separate array. That's all. This is what we call merge sort. This part of comparing element by element from the first and the second array and then merging them into a separate blank array, okay, empty array of size. If the size of first array is n, this size is m, we make another empty array of size n plus m, okay, and compare element by element, I and j, like the way I've shown you. Compare element by element in it, whichever is smaller, copy it at the first blank position of my empty array. This part is called merging. This part is called merging. This kind of sorting is called merge sort. Now tell me one thing. What I told you, recursion solves smaller problem. Solves smaller problem. Am I correct or am I wrong? For a bigger problem. For sorting this entire array,
Yes, sir.
what I can say, I can call recursion over both the halves. It will sort both the halves recursively. Can I say it will solve a smaller problem or not? Recursion solves smaller problem first for a bigger problem. Am I correct or am I wrong?
Correct.
Yes, sir.
So what I can do, I can recursively solve both the halves. I can recursively solve both the halves. 2, 6, 5, 9, 3, 4. I can call recursive function over this half and this half. And now whenever these two are sorted, I can say once I've called recursion over both the halves, these two are sorted. I will apply merging on it. Simply merge them. They are sorted now. And return this array. What else is required? Okay, let's code it and let's try how merge sort how merge sort looks like. Okay, define merge sort. What it will take array. Next, what it will take in. Fine. Okay, let's define another thing. Okay, now again, one condition. What will be the base condition for this? Recursion must stop somewhere, right? Recursion must stop somewhere. I cannot just keep on dividing the array and just calling it, right? Calling recursion over it. Where it will stop?
n minus 1.
What n minus 1?
Large.
Okay, tell me one thing.
Midpoint, sir.
If single element, if array has a single element, what we can say? It is already sorted. Can I say
Yes,
that?
sir.
It is already sorted.
If n is
Yes, sir. इसको best condition बना
I
देंगे.
minus 1.
If it is already sorted, do nothing.
Yeah.
Do nothing on it. That's all. Okay. Let's do one thing. Okay, yeah. If n equals 1. N equals 1. Do what? Return. Return from here as it is. No need to do anything. Okay, fine. Now next, let's do one thing. Let's do one thing. Along with this, let's keep a start and the end. 2 pointers, start and end. Because ultimately we have to divide our array, right? Ultimately. So what we can do is that we can calculate mid here. Mid as start plus end by 2. Now what I require? What I said, I will divide the array into 2 halves. Will recursively sort them. What I can say, merge sort, call the same function over the same array from start to the mid, and okay, if this is true, we don't require this anymore. From start to the mid, merge sort it, merge sort the first half, then sort the second half over the same array from mid plus 1. From mid plus 1 to what? The end. Can I say this? If this is my array, 0, 1, 2, 3, 4. Calculate the mid will be here 0, and I call merge sort from 0 to 4. Sort the entire array starting at 0th index and ending at the 4th index. Sort the entire array. What mid will be equal to? 0 plus 4 by 2 equal to 2. So mid will be pointing at this position. So what I will say, okay, take this first half 0, 1, 2, sort it first, and take the second half next. 3, 4, sort it next. And then whatever sorted result I have got, merge them. That's all. Okay, now how will I merge them? Can anybody tell me? How will I merge? Okay, let me draw it for you, and let us keep this 3, 1, 2, 4, sorry, 6, 4, let's say. Okay, what we will do? First half 3, 1, 2. This part is to be sorted first half. Next 6, 4 is to be sorted second half. How it will be looking like? 1, 2, 3. After calling merge sort over this portion. After calling merge sort over this portion, after calling merge sort over this portion, how they will be looking like? First will be looking like 1, 2, 3. Next will be looking like 4, 6. Now I have to merge them. How will I? How will I? Okay, let's keep I here at the start. Start was here, right? Mid was here. End was here. End was at this location. Let's keep I here. Let's keep J here. Now what will I do? Compare I and J. Let's make another array of size end minus start plus 1. Can I say this? This will be the size of my array that I require to merge my both halves. Both the halves are this. What size of the array I require? Extra array to merge this. To merge both the arrays. What extra array I require? What is the size? End minus start plus 1. What was my end here? 4 minus 0 plus 1. Is it equal to 5? So 5 is the required. 5 is the total number of elements and the required array in which I will be merging. The size of the required array in which I will be merging. Now I is kept here at 1. I is pointing to this one. J is pointing to this 4. 1 is less than 4. True or false? 1 is less than 4. True or false?
True.
So copy 1 here. Okay. So do what? Inside this merging array where I will be merging, let's keep another variable k, and that will be initially pointing to the 0th index. The 0th index of my merged array. Okay. What else we can do? Okay, yeah, fine. No problem on it. Now, whenever I have copied this one into the first position, increment the k by 1 into the next slot, next empty slot where I am supposed to do what? Where I'm supposed to do what? Merge the second element. Merge the second element. Now I will be going one step ahead. 2 and 4, compare 2 and 4. J is staying as it is. J is not yet filled, right? So J will be remaining pointing to 4 only. 2 and 4. 2 is lesser than 4. Copy at the kth position of my merging array. 2. Now increment k by 1. Increment k by 1. Okay, increment k by 1 and I by 1. Now again compare 3 and 4. Is 3 less than 4? Copy it here. Increment k by 1 here, and I will be now pointing outside this array. This array has ended. This array was sorted, right? This array was sorted. Am I correct or wrong? So whatever elements have been left inside this array, I can copy them one by one directly into the remaining space. Can I? This is sorted, so the order will be increasing only. 4, 6 is sorted, so 4 and 6. Even if I copy in this manner, this is sorted only. So inside my merged array, I am getting the full sorted array. Correct? So yeah, let's begin. Where my I should be pointing? Where I should be pointing at the start, and J should be pointing at mid plus 1. Am I correct or wrong? Am I correct or wrong? Now, for what condition this, till what time the merging will be going on? Till what time the merging should go on? So let's declare merge array. Okay. Merged array as an empty list initially, as an empty list. Okay, now I can say while I is less than, or equal to the mid, and J is less than equal to the end. Till the time this is true, I will compare now. If array of I, if array of I is less than array of J, do what? If array of I is less than array of J, inside the merged array, append array of I. Can I write this? If array of I is smaller than array of J, append array of I inside the merged array and increment I by 1. If this is not true, do what else? Do what? Merged array dot append. Merged array dot append array of J, and do what? Increment J by 1. That's all. Done this. Now this is a separate array, right? Merged array is a separate array, empty array. Inside, let's do what? Inside my array, inside the original array, copy these elements back. Okay, yeah, some part is left, I guess. Okay, what will happen? Likewise, we have seen here that, yeah, whenever I will be crossing the value of mid, 1, 2, 3, what happened? 4, 6 didn't get merged inside, right? After this loop, what will happen? If I take this case, 4 and 6 won't be merged inside the array. Why? Because this loop will be over. I is less than equal to mid, this condition will become false. So for that, we have to check separately. Is there any element that is remaining inside the first array? Then do what? Merged array dot append array of I. Similarly, I have to check for the second array also, whether any element is remaining there or not. Likewise, 4 and 6, 1, 2, 3 got merged initially. So 4 and 6 were left inside it, inside the second portion. They didn't got merged initially. So what I can do, I will check individually. I will check individually for each of the first half and second half, where if any of the elements inside them have been left, I will copy them in the order they are present inside the merged array. Okay. So what I can do, merged array dot append array of j. This part is done. Now this merged array is a separate array, right? This merged array is a separate array. Let's do what? Let's copy them. Just give me 2 minutes. Okay, now let's do what? Let's copy from start to the end for I in the range start to end plus 1 inside array of I. Do what? Copy all the elements of merged array. Whatever is the content inside the merged array, copy that back into the original array. And at the end, do what? Return the array itself. That's all. Return the array itself. That's done. So yeah, one thing I need to change here is here return will be the original array. The size of the array itself is 1, or rather, how can I know n is there? What I can write? If end is equal to the start, or the array has only one size, return the array itself. Then if this is true, that's what going to be a disaster, right? We have to store whatever array is being returned inside after this function call. That's what I didn't want it initially. So let's see. Let's store it as the first half, whatever this, and as the second half. Okay, these two arrays I will be getting after calling merge sort from the start to the mid, and then the mid plus 1 to the end. First half and the second half I will be getting. Okay, so now array won't be considered here. We have to compare the first half and the second half. And at the end, after merging, we can return the array as it is. Okay, fine. Let's define an array. What array you want? 6, 5, 4, 3, 2, 1. Let's say this is my array.
सर merge array dot append में भी तो first of I लेना पड़ेगा.
second half लिखना था आपने 56.
Oh, sorry. Second half.
उसी में एरे ऑफ,
इसमें
वही लाइन में एरे ऑफ आई कैसे आएगा?
एरे का तो कोई पोजीशन, ओके बताते हैं, ठीक है, जस्ट वेट करो।
अपेंड के अंदर बोल रहे हो।
अपेंड के अंदर सर, अपेंड के अंदर।
ओके, या सही बोला।
ऊपर वाली जो कंडीशन है उसमें भी चेंज होगा।
या बिल्कुल सही बोला, थैंक्स। हाँ, एक्चुअली ये मेथड में यूज करना नहीं चाहता,
फर्स्ट हाफ सेकंड हाफ ना,
ये मेथड में बिल्कुल यूज करना नहीं चाहता था, बिकॉज ये मेथड जो है ना, बार बार एरे रिटर्न कराना, ये सही नहीं होता है। पर बस पाइथन में कभी कॉल बाय रेफरेंस का कोई मेथड नहीं है, हर बार तुम्हें कॉल बाय वैल्यू पास करना पड़ता है।
सर बहुत बड़ा हो गया
कोड बड़ा ही होता है इसका, मर्ज सॉर्ट का।
इतना बड़ा सर?
यस।
अभी इतना कंडीशन चेक करते करते फिर टाइम कॉम्प्लेक्सिटी बढ़ जाएगा ना सर?
नहीं, कंडीशन चेकिंग पे
लाइन
टाइम
नंबर
कॉम्प्लेक्सिटी
45, लाइन नंबर 45,
नंबर 45 या
145 और उसके बाद में 49
फर्स्ट हाफ,
सेकंड हाफ।
सेकंड हाफ सही है।
हो गया।
ओके, यहाँ पे फर्स्ट तो नहीं, फर्स्ट हाफ होगा। ओके, एक काम करते हैं, इसको दोबारा से कोड करते हैं, बिकॉज बहुत जनों को कंफ्यूजन आ सकता है। नहीं, बहुत जन को दिक्कत आ सकता है,
एक बार दिखा दो,
बहुत जन को दिक्कत आ जाएगा। इसको दोबारा से कोड करते हैं, ठीक है।
सर हम लोग कैसे मालूम पड़ेगा कौन सी चीज के लिए कौन सी सॉर्टिंग टेक्निक यूज करें?
क्या
सर हम लोग को कैसे मालूम पड़ेगा कौन सी चीज के लिए कौन सी सॉर्टिंग टेक्निक यूज करें?
ये
वो तो
प्रॉब्लम
इंटरव्यूअर पूछेगा ना, सॉर्ट तो सिंपल सॉर्ट फंक्शन से भी हो जाता है।
इंटरव्यूअर्स की बात नहीं भाई, इंडस्ट्री की पूछ रहा हूँ।
इंडस्ट्री में सॉर्टिंग करोगे तब ना।
इंडस्ट्री में तो आपको फुल स्टैक डेवलपर में तो पाइथन तो काम आएगी नहीं भाई, आपका तो नोड जेएस वो सब एचटीएमएल और
ओके, शांत।
यस
If start equal to end, what I can say, start equal to end, do what? सौरभ, प्रॉब्लम आ रही है तुम्हारी तरफ से, साउंड आ रहा है। Start equal to end, what I can say, array is of length 1, return array, the base condition, right? If the array of size is 1, return that. Now let's define first half. Okay, let's define two halves, first half and second half. These are two separate arrays, second half and first half. Now let's calculate mid. Let's calculate the mid first. What will be the mid? Mid will be equal to start plus end by 2. Okay, now let's do one thing. Let's copy the first half. From start to mid, let's copy it into the first half. For I in the range start to mid. Okay, do what? Start to mid plus 1, sorry, same thing. Do what? Copy, sorry, first half dot append what? Array of I. Copy that. Copy contents of array from start to the mid inside first half. Similarly, what we can do, run another loop. From mid plus 1 to the end, do what? Copy whatever is the content inside array of I into the second half. Okay, this part is done. Now do what? Sort them individually. Merge sort. All merge sort on the first half. From its index 0, first half's index 0 to length of first half minus 1. That's all. Next, again call merge sort. Again call merge sort on the second half separately from starting index 0 to length of second half minus 1. This part is done. Sorted of both of them successfully. Now let's define a merged array. Inside I will merged array. And let this be initially empty. Right? Okay. Now what I can say? Let's define I to be both I and j initially to be at 0. Defined. Now I can say while I is less than equal to while I is less than first half, length of first half. And j is less than length of second half. While this is true, do what? Check the condition. If first half of I is less than second half of j. Second half of j. Do what? Merged array dot append first half of I. That's all. Done this. Else, if this is not true, one thing we have missed, right? What is it? I plus plus. Sorry, I equal to I plus 1. Increment I by 1. Next, if this is not true, what we can do? Merged array dot append second half of j and then increase the value of j by 1. This part is also done. Now I will check each of the array, first half and second half, whether any element is remaining inside that or not. What will happen? While I is less than length of first half. Till the time, do what? Merged array dot append first half of I. This part is done. Similarly, I will check whether any element is remaining inside the second half or not. While j is less than length of second half. Do what? Merged array dot append second half of j. The merged array I've got, return that. That's all. Return the merged array. Okay. So one thing that we have missed here, called this arrays, this function is returning, right? So we need to do one thing. So let's write it where we will store the whatever this first half I am calling. So first half from 0 to length of first half. This amount of array, first half of array I am passing. So some sorted array will be returned by this function, right? So let's store it somewhere. Sorted first. Let us store it here. And sorted second. Let me store it here. So yeah. So now I have to replace it. Sorted first rather than writing it. Sorted first and sorted second. This will be it. Sorted first, sorted second. Okay, I'm returning the merged array. After that, let's try merge sort. Okay, passing the array from 0 to length of array minus 1. Let's say. Let's try what result we are getting. Where things literals cannot be assigned. Let's see where have we done the mistake. Okay, yeah. Fine range. Okay, okay. System, right? No requirement of this. This can be done. Oh, sorry. I think we have missed one here. That is double slash will be there. Just wait. I will be taking your doubts. Let me clear up the code first. What is it? Maximum recursion depth exceeded. Some kind of error is coming today. Yes, tell me, Sahil. What's the issue?
सर हमने बहुत ज़्यादा complicated बना लिया program.
Merge sort is really a little bit complicated. You cannot.
बहुत सर easy से भी हो सकती है.
सर लास्ट का कोड दिखाइए ना.
एक मिनट ब्रो सब प्लीज आ जाओ, तो आप बोल लो जब मैं बोल लेता हूँ, क्योंकि ऐसे ना मेरा डाउट क्लियर होगा ना आपका होगा.
बोलो क्या हुआ?
नहीं, सिर्फ लास्ट का कोड दिखा दो, हम लोग बाकी काम करते रहते हैं.
ये देखो. ओह सॉरी, इट हैज गॉन मैन.
सर I is equal to माइनस लग रहा है.
Here I think I missed one thing, right? Let's run it. Maximum recursion depth increases 9911 times.
सर सिंपली हम एरे को मिड फाइंड करते और उसका
कर सकते हो.
एक सिंपली सबसे पहले मिड फाइंड करते, और जो कंडीशन आपने दी है, अगर वो कंडीशन की जगह हम लेंथ ग्रेटर देन 1 कर देते कि वो प्रोग्राम चलेगा ही, तब उसके बिना चलेगा ही नहीं. उसके बिना रिजल्ट सीधा एज इट इज ही आएगा. अगर लेंथ ऑफ एरे 1 सिंगल एलिमेंट रहता है तो एज इट इज ही उसको डिस्प्ले कर देगा, और अगर ग्रेटर देन 1 लेंथ आती है तो जितना भी आपका कोड है वो चलेगा. तो सिंपली उसमें क्या है कि पहले हम मिड फाइंड कर लेते, देन हम फाइंड करते उसका फर्स्ट हाफ, देन सेकंड हाफ.
Is it done? It's not.
रिवर्स
It remained as it is, right?
तो बहुत सिंपल हो जाता. मतलब एरे को फर्स्ट हाफ फाइंड करने के लिए भी आपने लूप जहाँ पे लगाई है ना, वहाँ पे सिंपली अगर आप मिड पहले फाइंड करते और फर्स्ट हाफ में सेमीकोलन मिड लिख के फिर मिड के बाद सेमीकोलन लिख देते, तो
स्लाइसिंग की बात कर रहे हो ना, स्लाइस करने की.
हाँ, स्लाइसिंग हो जाती. फर्स्ट में स्लाइसिंग मिड की इधर आ जाती, तो सेकंड में इधर आ जाती.
कर लेते हैं वही. फिर
फोर लूप्स आनी नहीं थी, दोनों ही फोर लूप बच जाती.
बात सही. जब पाइथन फीचर दे रहा है तो फिर इसको यूज क्यों ना करें, राइट? Array of start to the mid, right? Plus 1, and then second half will be array of mid plus 1 to the. Okay, so I am missing one thing here. And n plus 1 it will be, right? Not n only. Now let's see whether it's working or not. N by 2, where is it? Sorry.
2 बार लिखा.
सर इसमें भी एक स्पेस कम कीजिए.
इंडेंटेशन एरर दे रहा है.
हाँ
नहीं, हाँ एनोटेशन करें।
सर वो फर्स्ट
नेम
हाफ
फर्स्ट
सेकंड हाफ
हाफ
डिफाइन किए तो वो हार्ड ही है।
फर्स्ट हाफ डिफाइन कर दो। हाँ
चलो करते हैं।
सर सिंपल कंट्रोल जेड करो 2 बार आ जाएगा।
हाफ इक्वल टू दिस सेकंड हाफ। अरे हो गया। 1 2 3 4 5 सक्सेसफुली सॉर्टेड यूजिंग मर्ज सॉर्ट। Okay, let's do one thing. Rather than using the loops, let's slice my array of start to mid plus 1. Next second half, array of mid plus 1 to end plus 1, right?
कॉमा नहीं आएगा तो उसमें
सर
slice-
कोलन आएगा बीच में।
दे रहे हैं। And let's remove this. Okay, now call the merge sort function from the first half and second half. On the first half and second half, and inside whatever I have received inside sorted first and sorted second, merge that inside merged array. That's all. Okay, the explanation part of this code I am keeping it till tomorrow. I know you will be having some kind of confusions. Find the explanation of this code as well as the time complexity of merge sort we will take tomorrow, because the time is almost ended. Most of you will get confused how the merge sort is working. So let's take
Sir,
them. Yeah,
बहुत सारा कंफ्यूज।
merge sort related ना?
हाँ
ठीक है, कल करते हैं।
सर, इसमें ना आप जो वेरिएबल ले रहे हैं ना,
हम्म
फर्स्ट हाफ सेकंड हाफ, थोड़ा शॉर्ट में नाम लीजिए ना।
और पता नहीं लगेगा बाद में जब कोड
नहीं
करोगे
नहीं,
तो।
आप फर्स्ट में अभी इसको एफ डिफाइन कर दीजिए, फिर कमेंट कर दीजिए
लेफ्ट
कि
राइट भी
फर्स्ट
कर
हाफ।
सकते हो सर, लेफ्ट पार्ट राइट पार्ट।
See, I am running it once more.
हाँ,
Running it once more. The array was 6 5 4 3 2 1. Successfully getting sorted array 1 2 3 4 5 6. Merge sort is working. No problem on that. Some kind of coding error was there. Successfully have sorted using merge sort. Okay. So the explanation part of this as well as its time complexity I will explain tomorrow. Not going into further because you will get confused. So let's leave the code part tomorrow.
सर इसमें वैसे है ना, हम स्टार्ट एंड अगर नहीं भी लेते ना तो भी चलता। मतलब एरे की लेंथ को अगर इफ स्टार्ट एंड आपने डिफाइन किया है, इफ लेंथ और एरे ग्रेटर देन 1 तो प्रोग्राम चले, नहीं तो अगर लेंथ एक ग्रेटर देन 1 नहीं है तो जितना, मतलब उसका मतलब यही हुआ कि एक ही एलिमेंट है उसमें, है ना?
ठीक है, ठीक, सही बोल रहे हो। और ज्यादा सिंपलीफाई कर सकते हैं उससे।
हाँ,
ऐसा ही ना,
बहुत
लेंथ
ज्यादा।
ले लेते हैं, एरे ले लेते हैं, यही काम है।
हाँ,
ठीक है, चलो उसको मैं कल ये कर देता हूँ। Let's take the MCQs regarding insertion sort and a little bit of whatever we have discussed in merge sort.
फिर कल दोनों वाले बता देना।
ठीक है, ठीक है। We'll do it tomorrow. Code is completely fine. पर एक्चुअली बात है, तुम लोग को कोड दे नहीं सकते अभी, क्योंकि यहाँ पे कॉपी पेस्ट होता नहीं है, तो तुम लोग कॉपी नहीं कर पाओगे।
सिर्फ नीचे का बता दो ना सर।
बताओ कौन सा क्या है?
लास्ट लाइन
ये
हाँ, मेरे इसमें रन नहीं हो रहा इसलिए।
तो ठीक है, देखता हूँ, रख लो, डाउट है तो मैं देखता हूँ। Fine, we'll take this code explanation part and everything tomorrow, as well as the time complexity. Let's do the MCQs and we will wrap up today.
सर
बोलो।
आपका गिटहब वाला लिंक दोबारा दे सकते हैं क्या?
हाँ, दे दूंगा, कल दे दूंगा।
नहीं तो सर ये कोड दे देते हैं, हम थोड़ा एक्सपेरिमेंट करते हैं इसमें बैठ के।
हाँ ठीक है, कल दे देंगे,
भेज दूंगा मैं ग्रुप में।
कल मिल जाएगा ये।
सर भाई भेज दीजिए प्लीज।
किसमें?
मैं ग्रुप में डाल देता हूँ, मैं शेयर कर दूंगा इनको।
अच्छा ठीक है,
सौरभ ब्रो मेरे को भी सेंड कर देना हमारा।
okay, take the MCQs I'm giving. Please attempt the MCQs, all of you. Creating the attendance. All of you, please mark your attendance. And those who are not having any doubt can leave. सौरभ, कुछ पूछना था?
सर मेरे इसमें कोड रन नहीं हुआ इसलिए।
दिखाओ दिखाओ। शेयर करो। दिखाओ क्या है, हाँ प्रॉब्लम है। यहाँ पे ये करो, n+1 करो। हेलो,
लाइन नंबर सर
337, n+1 करो। ठीक है। दिखाना, रन करो, रन कराना। ठीक है। रन हो रहा है?
नहीं सर।
हाँ, दिख तो नहीं रहा है। दिखाना दिखाना, क्या एरर क्या दे रहा है?
कुछ भी एरर नहीं आ रहा।
वहां पे ये तो करो, रन तो करो, स्टार्ट डिबगिंग की जगह डायरेक्टली रन करो यहाँ से।
कंसोल से नहीं ले रहा सर, अटक गया।
क्या हुआ?
अटक गया शायद।
लगता तो भाई कंट्रोल Z मार के देखना है, कंट्रोल Z टर्मिनल में या कंट्रोल C।
10+1
टर्मिनल क्लोज करो, नया टर्मिनल खोलो, तब देखते हैं।
एक बार स्टॉप शेयरिंग करता हूँ,
ठीक है,
या फिर आप कर दीजिए।
अच्छा, ठीक है, कर दिया।
कुछ प्रॉब्लम है सर वो VS कोड का, मैं देखता हूँ उसके बाद में, तो कल देखेंगे।
कोड सही है ऑलमोस्ट, उसमें कोई बात नहीं।
हाँ मैंने आपके साथ ही टाइप कर रहा था बस।
स्क्रीनशॉट लेना है कोड का एक बार।
आप इसमें अपलोड नहीं करेंगे क्या आज?
करेंगे, आज तो नहीं, कल कर पाऊंगा।
तो मैं लेके
कल
रखता हूँ।
सुबह मैं कर दूंगा सारे सॉर्टिंग का।
आप चैट में नहीं डाल पाओगे? नहीं ठीक है सर, तो मैं ढूंढ लूंगा अगर कुछ एरर रहेगा।
ओके फाइन।
या फिर रिकॉर्डिंग है
Okay, fine. We'll discuss tomorrow what? Two things: time complexity and what?
dry run of code.
Yeah, dry run of the code. Okay, yeah. Thanks to all of you.
Thank you.
Okay, sir. Good night.
Yeah, good night.